In this video, we're going to be talking about converting a galvanometer into a voltmeter. That is galvanometer as a voltmeter. First things first, a voltmeter is simply a measuring device that helps to measure voltage, as the name implies, voltmeters. Okay. So similarly, like converting a galvanometer into an ammeter, we can as well convert a galvanometer into a voltmeter, because a galvanometer registers current, and in this way we can as well use the deflection. Okay, this arrow tells us the amount of deflection, so that same amount of deflection can tell us the amount of voltage that we are having. Okay, now to do this, we are going to connect a resistor in series with it. Why is that the case? Remember, for a shunt in our other video, we connected the resistor in parallel, okay, to the galvanometer, because we wanted the resistance in the circuit, that is the net resistance in the circuit, to be at its lowest form. Now in this case, we want the resistance to be as high as possible. Okay, so we are going to connect a high value resistance in series with it, but then the resistance we are connecting should be in such a way that it does not reduce the current that is coming into the circuit. Okay, because if it is too high, the current that we are going to measure, okay, or rather the voltage of the current that is coming in will not be the right value, because the resistance is just too much. Okay, so I'm going to fix in a resistance that is just okay to be the maximum resistance for the circuit, and still will not change the value of the current for the potential difference that we are to measure. So they are connected in series, and in this case the resistor is called a multiplier. Okay, that is why you are seeing M attached as the subscript of this guy. So Im is the current of the multiplier, which is same as the resistor. Okay, Rm the current of the multiplier as well, and then Vm current of the multiplier. Okay, I'm going to write this out. Okay, Im is the current of multiplier. Okay, it is the current of the multiplier. Okay, Ig is the current of the galvanometer. So Ig represents the current of the galvanometer. Okay, and then Vg and the likes, they can be done in the same way. Vg, Rm, Vm, Rg. Okay, these ones have similar meanings. Okay, so this one is for voltage across the galvanometer, resistance of the multiplier, voltage of the multiplier, and resistance of the galvanometer. Okay, now how are we going to find a formula that will help us to solve or create a particular resistance that is required to connect this galvanometer in series? Okay, to do that, we are simply going to apply our basic current electricity rules. Now we notice that they are connected in series, so it means the current in the multiplier is equal to the current in the galvanometer. Okay, now from Ohm's law, we do know that V is equal to IR, so we can make I the subject. This becomes voltage in multiplier divided by resistance of the multiplier, and it's equal to voltage of the galvanometer divided by the resistance of the galvanometer. From here, we want to solve for Rm, so it means that Rm is simply equal to Vm times Rg divided by Vg. Now here is the formula. Okay, Rm is equal to Vm times Rg divided by Vg, of which Rm is the what? Resistance of the multiplier, Vm voltage of the multiplier, Rg resistance of the galvanometer, and Vg voltage of the galvanometer. Now, can we make any more substitution in that formula? If you check, you notice that there is a voltage here and there is a voltage here, and also a voltage of the source. Okay, it means that when we combine Vm and Vg, we should get the total voltage, right? And we can then substitute. This means that Vm plus Vg equals the net voltage in the circuit. So I can choose to substitute for Vm, of which Vm is then going to equal V minus Vg. Substituting into the formula, that gives us Rm to equal V minus Vg, okay, times Rg divided by Vg. So here is another useful formula for solving it. Now, like I always say, these formulas are not to be crammed, but rather are meant to be understood. All you have to do is understand the concept. For a shunt, we are connecting a low resistance shunt or a low resistance resistor, okay, so the galvanometer in parallel, in order for us to convert it into an ammeter. Okay, and then for a voltmeter, we are going to connect a high resistance multiplier in series to the galvanometer in order to cross it into this guy here, the voltmeter, in order for us to measure voltage. Okay, and how do we determine the value of the resistance? Using this formula: the voltage that is coming in minus the voltage of the galvanometer times the resistance of the galvanometer divided by the voltage of the galvanometer. Okay, so that is how problems like this are being solved. Okay, in our next few videos we'll talk about more about galvanometer and shunts and multipliers as well. Do like to drop a question in the comment section if you have one, and if you did get something for the video, don't forget to smash that like button, smash the subscribe button, and also click on the notification bell so that when new videos are being uploaded as usual, you'll be one of the first few persons that will get notified about it. See you in the next video. Bye.